In today's video, we will be going over how to compute the determinant of a square matrix. First, let's go over how to compute the determinant of a 1 by 1 matrix. Suppose we have a 1 by 1 matrix A with the entry small a. Then the determinant of this matrix will just be the one entry inside of it. Now let's go over how to compute the determinant of a 2 by 2 matrix. Suppose we have a 2 by 2 matrix A that has the entries A, B, C, D. Then the determinant of this 2 by 2 matrix will be given by AD minus BC. Now let's go over an example of computing the determinant of a 2 by 2 matrix. Suppose we have a matrix A that has entries 1, 2, 3, 4, and we want to find its determinant. Remember that the formula for finding the determinant of a 2 by 2 matrix with entries A, B, C, D is just given by AD minus BC. So let's plug the entries inside of our given matrix A into this formula. So the determinant of A will just be given by 1 times 4 minus 2 times 3, which is equal to negative 2. Now let's go over how to compute the determinant of an n by n matrix. Let's suppose we have an n by n matrix A with entries Aij. The determinant of A will be given by this formula right here. Notice that in the formula you're indexing over I, but you're keeping j fixed. So really you're going through the jth column and going through each of the entries. And here Aij denotes the entry that is in the ith row in the jth column of the matrix. And determinant A of Aij is basically just the determinant of the minor matrix Aij, which is the matrix A with the ith row and the jth column removed. Now it turns out that in fact we can actually compute the determinant by expanding along any row or column of the matrix. So previously the formula of the determinant that I put up involved indexing over I. But actually we can also index over j. So basically this would correspond to going through each of the entries in the ith row of the matrix. Now let's do an example which involves computing the determinant of a 3 by 3 matrix. Let's find the determinant of the following matrix. Suppose we expand along the first row. I'm going to leave the formula for finding the determinant of an n by n matrix here just for your reference. So we'll just plug in the numbers in our matrix into our formula. Notice that A11 entry will just be 1. So we'll have 1 times negative 1 to the power of 1 plus 1 times the determinant of A11, which is basically the minor matrix that we get when we take out the first row and the first column of A and just take the remaining entries. So this would be the matrix with the entries 5, 6, 8, 9. So in the next term of the summation, we're going to take A12. So A12 is going to be the entry 2. So we'll have 2 times negative 1 to the 1 plus 2 multiplied by the determinant of the minor matrix A12. So this is going to be the matrix that we get when we take out the first row and the second column of A. So this will be the matrix with the entries 4, 6, 7, 9. And for the third term in the summation, we'll have A13. So A13 in our matrix is just going to be the entry 3. So we'll have 3 times negative 1 to the power of 1 plus 3 times the determinant of the minor matrix A13. So this will be the matrix that we get when we take out the first row and the third column of the matrix A. So this will be the matrix with the entries 4, 5, 7, 8. So now all we have to do is compute the determinants of our minor matrices. Remember that the determinant of a 2 by 2 matrix with entries A, B, C, D is just given by AD minus BC. So the determinant of our matrix A is just going to be 1 times negative 1 to the 1 plus 1 times the determinant of the matrix 5 with the entries 5, 6, 8, 9. So this is just going to be 1 times the determinant of the matrix with the entries 5, 6, 8, 9. So this is going to be 5 times 9 minus 6 times 8. The second term in our summation is just going to be 2 times negative 1 to the 1 plus 2 times the determinant of the matrix with the entries 4, 6, 7, 9. So that's going to be minus 2 times the determinant of the matrix with the entries 4, 6, 7, 9. So that's just going to be 4 times 9 minus 6 times 7. The third term in our summation is just going to be 3 times negative 1 to the 1 plus 3 times the determinant of the matrix with the entries 4, 5, 7, 8. So that's just going to be 3 times the determinant of the matrix with the entries 4, 5, 7, 8. So that's just going to be 4 times 8 minus 5 times 7. So if you simplify this, you should get 0. So the determinant of the matrix A will just be 0. Let's do another example. Let's find the determinant of the 3 by 3 identity matrix. Let's suppose we expand along the first row. Here's the formula for finding the determinant of an n by n matrix. The determinant of A will be given by A11 times -1 to the 1 plus 1 times the determinant of A11 plus A12 times the -1 to the 1 plus 2 times the determinant A12 plus A13 times -1 to the 1 plus 3 times the determinant of A13. So we'll have 1 times -1 to the 1 plus 1 times the determinant of the minor matrix A11, which is the matrix that we get when we remove the first row and the first column of the matrix. So this will basically just be the 2 by 2 identity matrix. So we have 1 times -1 to the 1 plus 1 times determinant of the matrix with entries 1, 0, 0, 1 plus A12. So A12 is a 0 times -1 to the 1 plus 2 times determinant of A12. But since A12 is 0, this entire second term just gives us 0. Now similarly, A13 is 0. So the entire A13 term, so A13 times -1 to the 1 plus 3 times determinant of the minor matrix A13, that's just going to give us 0 also. So the determinant of A will be given by 1 times -1 to the 1 plus 1 times determinant of the matrix with entries 1, 0, 0, 1. So 1 times -1 to the 1 plus 1 is going to give us 1. And the determinant of the matrix with the entries 1, 0, 0, 1 is just going to be 1 times 1 minus 0 times 0. And this entire thing simplifies out to be 1. So the determinant of A is just 1. So that's all I have for this video. If you have any questions or concerns, please let me know down in the comment sections below. Thanks for watching this video. Hopefully that was helpful. Hope to see you in the next one.